Good morning, Algebra 2. We had one request for a problem from the Chapter 12 Reteach problems, and it comes from Reteach Chapter 12, Section 3, and it was for number 2. Here we have the sequence of numbers of 4, 8, 16, all the way up to 2048. And they want us to do is they want us to add up those sequence of numbers, which becomes a series. So it's 4 plus 8 plus 16 plus whatever, all the way up to plus 2048. And we want to add up these terms. First thing we got to do is we got to ask ourselves, is this a geometric or an arithmetic series? Well, we know that the first term is 4, and we know we can check by seeing if it's an arithmetic by looking at what's happening from 4 to 8. And we see it's increasing by 4, and then we see from 8 to 16 it's increasing by 8. So that tells us right there that this is not an arithmetic sequence / series. So that leaves us with a geometric. So we ask ourselves, how do we find the common ratio for this geometric sequence or this geometric series? So you take the second term and divide it by the first term, and you get an answer of 2. Now you could have done the same thing by taking the third term and dividing it by the second term. You'll still get a common ratio of 2. So this tells us that this is a geometric sequence. We want to treat it as a geometric series, and we want to add it all the way up to 2048. So it has a common ratio of 2. And the next part is we got to ask ourselves how many terms we have here. Well, we know that this is the first term, this is the second term, this is the third term, but we don't know what term this is. Well, I've already written down 10, and I got that by going over here to this side of the page. Using the geometric sequence formula, we know that the first term is 4. We know the common ratio is 2 raised to the n minus 1. It has to equal 2048. So what we're doing here is we're trying to figure out what term 2048 is. So first thing we do is we divide both sides by 4. So if I divide this side by 4, this 4 is eliminated, and I'm just left with 2 to the n minus 1. You take 2048 and divide it by 4 itself, and you'll get 512. Now the next part is we see that the left-hand side has a base of 2. So what we need to do is we got to figure out if 512 also has a base of 2 using our power rules. Well, we know that this is a perfect square, a perfect number. So all I did is I just started plugging numbers in. But I do know that 2 to the 9th is 512. I did that on my calculator. So I know now the right-hand side is 2 to the 9th. Then the next stage is we know the left side and the right side have the same base of 2, so we can use the 1 to 1. So that means n minus 1 has got to equal 9, and solve for n. And that tells us that 2048 is the 10th term of this series. So now that we know what's the 10th term, then we have to use our geometric series formula, which is the summation of the first 10 terms becomes the first term multiplied times 1 minus the common ratio raised to the n, which we know it's 10, all over 1 minus the common ratio. Then the next part is just calculator work. Now again, I try to go and do each step here, the numerator numerator and the denominator one at a time, so there is no error in doing my calculator, doing the calculation. So it's 1 minus 2 raised to the 10th, and we get negative 1023. And I know 1 minus 2 is negative 1. Then we know that negative divided by negative is positive, and 1023 divided by 1 is 1023. So you take 1,023 and you multiply it times 4. 1,023, and we get 4,092. So if we add up all 10 of these geometric sequences, it becomes a series. Its sum is 4,092. Now again, probably the key to doing this problem is all over here. You got to be able to ask yourself, what is this term we need to include, we have to be a part of in the adding up. So this is the part that's you have to really focus on. The formula setup is not that difficult. It's setting this up. All right, guys. Catch you later. Bye.